My dear friends, welcome to Rajshekhar classes on applied data science with Python. This is lecture number 589. In this lecture, we will try to understand Word2Vec algorithmic optimizations. So, in the previous lecture, we saw both CBOW and skipgram. But before understanding this particular lecture, I request all of you to go through this particular slide. This is a summary of my previous slide. If you recall, in the previous lecture, we saw both for CBOW and skipgram. There are lots of weights. There are almost millions of weights that you have to compute, which can make the problem extremely time taking to solve. So there are two primary algorithmic optimizations. One of them is called hierarchical softmax. Hierarchical softmax is an algorithmic hack. Second thing is called negative sampling, which is basically like probabilistic or statistical technique. Let's start with the hierarchical softmax. Remember, one of the hardest operations in both skipgram and in CBOW is optimizing the training of softmax. They take lot of time because just if you observe this one, this will not take much time. Linear units, this linear activations units will not take much time, whereas the softmax units will take much time, isn't it? Because the softmax units take a lot of time. The linear units which are in hidden layer will not take much time. Computing these linear units is not a difficult task, but computing softmax is harder part. Harder part here is computing softmax. Here you have softmax units. They try to optimize computation of softmax. Even in the case of CBOW, just see, in the case of CBOW, you have softmax units, isn't it? You have V softmax units here, V dimensional softmax unit. Just try to recall, this is V dimensional, this is V dimensional softmax unit, isn't it? Just try to recall, I discussed this concept in my previous lecture. In the case of skipgram, you have V dimensional, just see, in the case of skipgram, you have V dimensional softmax, but you have K such softmaxes. So the core idea is, can you somehow optimize the V dimensional softmax to make it optimal, isn't it? So the core idea of hierarchical softmax is, can you somehow modify V dimensional softmax with V outputs to make it optimal? That's the core idea here. So your V dimensional softmax looks like this. You have V units in this one. Just see here, you have, it's V dimensional, you have V units, you have V activation units in V softmax. So the core idea is, can you somehow modify this? And this is like a linear structure. Just see, this is linear structure. There is a structure, there is a data structure called binary tree, isn't it? This is V class classification. If you observe, this is V class classification because output word can belongs to any one of the V classes, one of the V words in vocabulary, isn't it? Let's say, let's assume my vocabulary is with 8 words. What are those 8 words? V equal to W1, W2, so on, W8. In place each of my words as a leaf nodes of this tree. I am constructing a tree. Let me say this is a binary tree. This is like sleeping tree, isn't it? It is just like a sleeping tree. We actually here W1, W2, W3, W4, so on W8. They are representing leaf nodes. That's important here, isn't it? Typically we draw the trees like this, isn't it? Here, just typically we draw the trees like this, isn't it? We can place just see, we can place these words, as the leaf nodes of this binary tree. Just see, all these are leaf nodes, I'm placing all these words like this. Typically we used to draw tree like this, isn't it? I'm drawing slightly differently by making each of these leaf nodes are the words. Here idea is I'm keeping each of the leaf nodes as a word. Instead of drawing like this, I'm drawing my tree just like a sleeping tree, nothing more than that, isn't it? Each of these leaf nodes are the words that I care about. How many words I have here? W1, W2, so on, W8. What am I doing? I am keeping them as the leaf nodes. So the first node says, what it literally says is, if I break, just see, break this tree. If I break this tree by using first node, it has the half of the words in this side. Just if I break, what happens? Just see, half of the words. If I break by using first node, what happens? I am breaking like this. This portion, I have half of the words in this portion, and it means above this particular line, I have half of the words. Below this particular line, I have half of the nodes. That's what it says. If I break this tree by using first node, it has half of the words in the above. Half of the words is in this side. In this side means W1, W2, W3, W4. It has half of the words in below that horizontal line. They are W5, W6, W7, W8. So instead of trying to create V-class classifier, I will create a binary classifier. That is important. I will create a binary classifier. Just see, what am I doing here? I am creating a binary classifier here, which says does the output word belong to first half or not, isn't it? Does the output word is a V-class classification? Instead of doing it as V outputs, I am trying to create a hierarchical structure. So let's take a vocabulary of size 8. Here I have 8 words, isn't it? How many words I have here? 8 words. This is a binary activation units. I have 8 words. Let me say this is word. This is word corresponding to W1, isn't it? Let me say this is a word corresponding to W1. Just see, I have 8 activation units corresponding to W1, word 1. This is a word corresponding to word 2. This is a word corresponding to word 3, word 4, word 5, word 7, word 8. I will get the probability that my output is word 1. Probability of my output is word 1. The probability that output is word 2. Probability the output is word 8, isn't it? So I have 8 activation units here, isn't it? How many activation units I have? I have 8 activation units here. What I am doing here is, first activation says whether the output whether the output is in first 4 words or second 4 words, isn't it? Is it in first 4 words or in second 4 words? This is a binary activation unit. Suppose this says that the probability of my output belongs to first 4 words. Let me say probability. Let's suppose this belongs to first 4 words. Let me assume. Suppose this particular activation unit says that my output belongs to the first 4 words is high as compared to the second 4 words, isn't it? That's what this probability is higher. This 4 words probability is higher compared to these 4 words probability. Means above this particular horizontal line, this probability is higher than this probability, isn't it? That's what I am saying, isn't it? Let me assume. Suppose this particular activation unit says this particular, let me assume this particular activation unit says the probability of my output belongs to first 4 words is high as compared to second 4 words. Then I come here, where will you go? In that case, where will you go? Certainly you will go like this, isn't it? You will be here. Now where are you? You are here. Now you will come here, isn't it? Yes. When I come here, I will break this tree into 2 parts. Break this subtree into 2 parts. Now I am in this, at this particular node. Now I am breaking this. Just let me assume. Just see. Again I am here, and again I am breaking, isn't it? Yes. It is an output. Is it output word is first or second? Is it the third or fourth? Now is it the output word is in first and second or third and fourth? That I have to decide. Let's assume it says third and fourth. Let it be. Let me assume it says third and fourth, isn't it? Let it be. Then I will come here. If it says this probability is higher, then where will you come? I will come here, isn't it? I will come here. First I started here, then I came here. Now I am here, isn't it? So instead of 8 activation units, I just needed 3 activation units, isn't it? Instead of 8 activation units, this one, isn't it? This one is first activation unit. This one is first activation, second, third. Instead of 8 activation units, I just needed 3 activation units. And here I will get probabilities. Whose probabilities? Probability of W3 and W4. Let me assume my probability of word 3 is bigger than probability of word 4. In that case, what I will get? Probability of yi equal to 3 given xi. So if I have V words, let me assume V means 8 here, V activations here, isn't it? I just needed log V activations here, log V base 2, isn't it? It is basically log V base 2. Here V is 8, log 8 base 2. That is basically, that is 3, isn't it? That's what it says. If I have what it says, so you just need 3 activations here instead of 8 activations, isn't it? 8 activations you have here, which means you are creating a hierarchical softmax where the number of activations you need to determine the final probability. So what are you trying to do? You are trying to predict the probability of yi equal to 3 given xi. In softmax, that's what you are trying to predict. To predict, instead of having 8 softmax units here, I just need 3 binary softmax units. This is an optimization of hierarchical softmax achieves. This is an algorithmic hack. Anybody who studied computer science will know. Instead of using linear methods, binary tree based methods are efficient. This is like a standard algorithmic stuff. The second idea, very interesting idea, is called negative sampling, which is statistics based technique or the probability based technique. Yes, the way it works is this. For any output, you have V-dimensional output. Just try to recall what is the output. You have V-dimensional output. You have V-dimensional output here. At the end of the day, I have to update everything. I have to update my weights. The core idea here is you update only a sample of words. Here you have V words. Let me assume you have V words. In these V words, I will update only a sample of words. Instead of updating everything, just update sample of words per iteration. Don't update everything. Your time is saved enormously, isn't it? How do you choose And how do you sample this? Here only update a sample of words, but how do you define the sampling technique? That's the sampling technique is always in this particular sampling technique. What you have to do, always keep target word. Target word, what I mean is the word you care for, isn't it? That is target word. The word the word you care for is target word. Suppose, imagine the output you want is third output. Let me assume, I am assuming output I want is third output. Therefore, third output is set to 1, isn't it? Everything will be set to 0. This is the only third output is the only this is the only target word. Third output is the only target word. Keeping everything corresponding to target word, don't touch that one. Keep that target word and set all other words to 0. That is step number 1, isn't it? Amongst all the non-target words, which basically means W1, W2, here I am not taking W3, I am keeping as it is. Why? Because it is target word. Amongst all the non-target words, which basically means W1, W2, I am not taking W3 as it is target word, I am taking W4, and all of them. Don't update all the words here. Don't update the weights corresponding to all the weights here. Just update the weights corresponding to sample of them. Only a sample of them, isn't it? That's important. Only a sample of them you have to update. How do you sample? We can sample probabilistically as follows. Probability of sampling a word Wi is P of Wi equal to 1 minus under root of threshold. Here tau means threshold of frequency of word I. And typically tau means what? Tau is a threshold value. Typically its value is 10 power minus 5. So let's understand what is this probability is doing. This probability is literally, you can write this probability as probability of picking a word P of Wi. Let's assume my word is very, very frequent. Let me assume my word is very, very frequent. In that case, what happens? And there is a reasoning why this if it is very, very frequent, what happens? This tau by under root of tau by frequency of Wi becomes very small. In that case, 1 minus under root of tau by frequency of Wi is very big, is high. And there is a reasoning why this form of probability picking is used. In a nutshell, what am I doing? Instead of updating all the weights, you update only sample of words. That is important. Just read this particular slide. In a nutshell, what I am doing, instead of updating all the weights, you update only sample of words, such that the target one is always kept amongst the non-target words. We sample them based on the frequency, based on the formula P of W equal to 1 minus under root of tau by frequency of Wi. In this section, I also refer, I referred one nice blog. I would like to show you that blog. Anyway, I will provide link for this blog in description and comment section of this particular lecture. I request all of you to go through this blog. It's a well written blog, a simple Word2Vec tutorial. He explained overview of Word2Vec and model overview, isn't it? Just to go through this representation. Just see, this is simple thing. Just I referred this particular blog for this lecture. Just see this, what is the formula here, formula which we are using. What is P of Wi? Everything you can find here. Just see, just go through this one. This is a very, very important blog. Just see, here you can see what you can see, just different techniques. Just see, this is a formula which we are using. P of Wi equal to 1 minus under root of, instead of t I am writing tau, f of Wi. Just go through this blog. This blog is one of the best written blog. As I told you, I will provide reference in description of this video. I also provide that particular one. Please note here you can, it starts with please note that both for hierarchical softmax and negative sampling, what I provided here is only an intuition, is only intuitive explanation. Mathematics of it is beyond the scope of this particular lecture. But if you are interested to learn the deeper mathematics, you are most welcome, and just Google search for hierarchical softmax and negative sampling. You will get tons of articles. Just go through this lecture. If you have any difficulty, please keep a comment. Thank you very much.